Yes, now welcome back, my dear friends. Now, at the time power has gone, we are teaching, we are learning power plant engineering. The power is gone. For that, somewhat a little bit, the shade of my face also will come as a block. Sorry for that interruption. So now we will see that what is that? There are types of condensers will be there. So low level jet condenser, parallel flow type condenser, counter flow type condenser, counterflow type condenser, and high level jet condenser, ejector jet condenser. Now we will see that one condenser, low level parallel flow condenser. Here see that one tank will be there. This tank, you please kindly observe this figure. Uh, Exhaust steam from turbine, it is coming. The exhaust steam is coming from the turbine. So that exhaust steam turbine is coming. In between that, we are going to sending this cooling water to that condenser shell. Okay, so that cooling water, and with the help of cooling waters, there is a nozzles will be there. That nozzles we are going to spraying on that. Whenever the steam is entering into that chambers, so that in that chamber, the steam is going to be mixing with this cooling water, and it is converting into that water. At that time, the water will be that hot water will be there. Means I can say that. So why? Because steam is in position in that 100 degrees centigrade. So at the time, again, earlier we saw that one figure. In that figure, again we are going to sending that cooling water to that condenser. That is our by seeing of we learn these two figures. We want to that steam we have to convert into that water. That is our main aim, main object. So here we are sending that water, and we are going to sending that cooling water to that condenser shell. Condenser tray, we can say that. So that trace will be there. Perforated trace will be there. That perforated trace from 1 point to 2 point, 3 point, like that trace, it is going down. That temperature is also going down. At the same time, the what I mean to say, uh, and it is going to be becoming as a water. That is that. We are going to showing that perforated trace 3. There are number of perforated stages. So finally, see that if it is there, air will be there. Air, in water, air will be there. From turbine also, the steam is coming now. So over there, air will be there. So wherever empty space will be there, air will be occupied. So generally in the water, air is there. So that air is also we are going to remove. Over there also that steam is, means I can say that hot water is going to be becoming as a cold water. So whenever we are going to removing that temperature, means heat. So that condensate and coolant, if sometimes we are going to mixing with to reduce that temperature of that water, again we are going to mixing with the coolant. So that coolant is going to come in, and then this condensate extraction pump will be there. From that pump, we are going to sending that hot well. See, over there we are not discussed about if that hot well is overflow, means mark level tank, that hot well tank is level is more than that water. That water flow will go to that cooling water. One more we can say that the chambers we are going to providing, and then we are going to sending this one. Okay, so that is that one of the part will be there. Okay, so here that is the thing will be there. Okay, another one more this is that we are going to seeing that one. Okay, that again that hot well we are going to feed into that water will be there. Okay. So here I taken from this one of the means these figures I collected different areas I collected over there. So another one more thing you can see that to this is that one more another type we can say that low level jet condenser, low level counterflow jet condenser. See same over there air pump we arranged exhaust stream over there we kept over there. Here we can arrange the air pump in the top. Here is where steam is going to be coming. So steam is going up and cooling water is striking up. Both are mixing very means mixing is very clearly. So over there we are going to getting very easy to mixing that water. That's very most one of the advantage. Another one more thing we can see that here same perforated trace will be there. Water spraying is there. Cooling water is entering. This condenser shell is there, and condensate. This entire liquid we can say as condensate. So this condensate extraction pump will be there, and then we are going to sending to that hot well, and hot well to feeding to that boiler, and this cooling water we are going to making. If it is overflow in that hot well, we are sending to that again to that cooling water. If it is any other source will be there, we are going to seeing this. We are going to seeing. What I mean to say, we are going to, again we are reducing the temperature of the steam. That's our motto, to reduce the temperature and to increase the temperature. These two things we are going to doing entire this condensers. So here also you see that high level condenser, same air pump is that top portion, top area condenser in the condenser shell, and steam that exhaust steam coming from the turbine. We are going to arrange the downside of the shell, and water sprays will be there, condensate and cooling is there, cooling water circulating pump is there. Okay, okay, here we are another one more overflow pipe, same thing will be there, but here is only over there, here this from this tile pipe we are arranged. Over there one feed pump we are arranged, earlier one. Here we are directly arranged one tail pump, tailpipe. Why? Because again over here the temperature of the means the uh, temperature of the water is again we are going to decreasing over here. So it is flowing through that pipe. Some of the surroundings, the heat is going to be carried away by it to that tail pump. So again we are going to sending to that hot well. That's a different issue. Okay. So again feed water and overflow pipe will be there. All the things we are going to sending. Okay. Another one more thing is there. Uh, Ejector condenser. So that ejector condense cooling water is coming over there. Cooling water nozzles will be there. Non-return valves will be there. Exhaust stream from the turbine. Okay, we are going to controlling over here exhaust stream through that non-return valve. Suppose if it is more will be there, we are unable to, we are going to controlling with the help of this thing, and directly we are going to sending from the top this cooling water. In this, we are not having, in this, we are not having that, we are not having that to remove that air, to remove that air. That is that one of the thing is there. We are not going to remove that one. So that is a non-return valve, and the ports will be there. Divergent cone will be there. Over there again it is velocity is increasing, that condensate, and we are going to send into that hot well. Okay. See, by observing this figure, so they, what is that another one more part is not there. One more part. Which part that is? That is air removing valve is not there in this. That is that one of the the disadvantage for this ejector pins. Another one more thing is there, jet condenser. So in that jet condenser, we are having advantages. So many advantages will be there. Jet condenser, low quantity of cooling water is required, and simple in design. Cost is very low, and less space occupied. Okay, requires less floor space. Okay, and then lower capital and the maintenance cost will be there. Very lower capital, very less cost will be there. Due to direct contact heat transfer is more effective. Is more effective. And next, what are the disadvantages from this one is that, what is that disadvantage? Condensate cannot be directly used as feed water. Power consumption in the pump is more. Piping cost is more. Piping cost is more. And now coming to the picture of surface condensers. In that surface condensers, we are having, according to the number of cooling water passes, there are number of tubes will be there. With that tubes, we are going to manufacturing single pass condenser and a multi pass condenser. According to the direction of condensate flow, down flow condenser and central flow condenser. Down flow condenser and central flow condenser. Okay, there are again surface condensers. We are having another two types of condensers will be there. Another, this one, you see that it is very double pass surface condenser. See that how many tubes we are arranged inside. Cooling water out, water box will be there inside, cooling water in, cooling water out. So entire this water is going and coming and it is circulating over there, the entire shell, condenser shell, and it is going out. Exhaust steam is coming. Through that it is passing, it is also combining with that steam. This cooling water with that, it is going to be coming like steam is going to be converted into that water. Steam is going to converted into that water. That is one of the surface condensers advantage. Means we can easily, there is no like that, somewhat little bit tough in that one. So here there is no need of that one. Okay. Another exhaust steam from turbine, same, means arrangement are different. Here is a number of tubes will be there, water in, water out will be there, condensate is coming. Okay, from the, it is entering into the condenser shell. Tubular plates will be there. So, but the efficiency is more this type of condensers. This efficiency is more double pass surface condensers. Double pass surface condensers. Okay. Next we will go for another down flow surface condensers. Down flow surface condenser. So in down flow surface condensers, we are having in down flow surface condenser, exhaust steam from the turbine it is coming. Over there, number of tubes will be there. Here one more technical term is there, baffle plate. Here, air cooling system. So here the baffle plate is going to segregating that exhaust steam from the turbine, and that air is to be extracted. That is the main advantages. See, here that steam we are separating, and air we are going to separate. When we are going to removing the air, automatically that condensate is going to be becoming as a water. Whenever you are losing that temperature, automatically it will go for it will reduce the temperature. It will go down. The temperature will go down. So that again will be there condensate, even though if you are going to doing. So here we are going to sending this air cooling section. This is a passage that all are rounds one air cooling pipes. We are going to sending to that air, and then it is going to be becoming that mm, water, hot water. Okay, that steam is going to be converted into that hot water. That is that one of the technique for this one. Okay, another one more type we will see, that downflow surface condenser. Downflow surface condenser. In this downflow surface condensers, so steam will be there, tubes will be there. Clearly, I'm over there in the middle, baffle plate. Why we are going to putting this baffle plate means that we are going to separating air tubes and condenser tubes. It is going to be dividing by air tubes and condenser tubes. Okay, so that is that main advantage for that one. Okay, so with that tubes will be there, steam and air is over there. We are going to sending earlier condenser, we are going to sending that only for steam. Here we are going to sending into that condenser air and steam, air and steam. So whenever it is entering into that condenser, so almost all that steam is going to be converted with the water. See how many different types we are going to seeing. See by that side, you can see that how that sectional view will be there. Condensate is coming, air is coming. Condensate is coming, air is coming. So that here cooling water is there. Cooling water is there. Cooling water is entering, and again it is going to be there. Air is we are going to removing. Over there heat means we are going to removing that heat with this using of this cooling water and as well as air. So air is entering, air is already entering with that steam. So that here efficiency is going, is volumetric efficiency and efficiency, thermal efficiency is increasing in this type of condenser. This is that the big advantages for that one. So now we will see that another one more condenser, central flow condenser. Central flow condenser. So central flow surface condenser, same thing will be there. Exhaust stream from turbine, condenser tubes will be there. In that condenser tubes, air cooling section separate. From that striking of that steam is striking to that air. Over there again we are reducing. Here entire shape is different. Concept is one. We have to remove that temperature from that steam. We have to remove that hot means temperature from that steam. So we are removing that one. Different methods. Steam is entering one side, steam and air is entering. One side we are removing that air. One side we are going to providing that air cooling sections. But finally we are going to sending to that hot well. We are going to converting steam into that water and we are sending. That is our main objective of this one. And next condensate is going to that. We are not speaking always, I am not speaking water. The condensate means 50 means maximum percentage of water and the remaining percentage is steam will be there. That is called as condensate. And evaporative condenser. See that how many different types are there. Means different things are there. You please clearly you can observe it. Okay. So here you see that how much equipment will be there. Air is going to outlet. So here we are arranged fan. Air is going out, and then here eliminators are there. Eliminators are there. Air is going out means the hot air we are going to remove with the help of fan. With the help of fan. So that here, that is the thing. The drift will be there. These are the passages, how that air passes. Here that sprinklers will be there, or sprays are there. So it is entering. The water is entering. And here also, whenever you are spraying that one, here steam is going to be cooled up. So cold fluid in, hot fluid in. So hot fluid means it is indirectly nothing but steam. This cold fluid means water will be entering. Over here, air is also we are sending. So both sides we are going to sending that air. So again, it is the thermal efficiency is increased. The thermal efficiency is increased. So here, water basin cooling water will be there. That we are going to sending this water extraction pump. From that again, it is going to that. I can say that it is going that cooling water to that sprays. Okay, all these things, if you are observed very clearly, so entire process is removing the heat and adding the heat. Okay, removing the heat and adding the heat, so that this different shapes of condensers we are going, and differently we are going to achieving our object. Okay, that's one thing. Now we will see that next condenser, evaporative condenser. We will see that in that evaporative condenser, one more thing I will say. I will discuss at the last end that TEMA, related to TEMA. Air from the atmosphere, whatever air we are going to remove with the help of draught fans. We are going to remove that draught fans. Okay, so eliminators will be there. From that eliminators we are going to remove. Water nozzles is there. Jets or nozzles, sprays, whatever the terms we are going to use. That spraying over there. The exhaust stream is entering, and the condensate from the pump it is going out. Okay, condenser coils, all these things. Air in and the air out. Both sides we are sending that air. Means all these things are valves. Okay, throttle valves you can say that. So that from that throttle valves it is going up. And another thing is there here. Cooling pond will be there. From that cooling pond we are going to sending. We are storing here this entire water over here. Okay. Another this thing, evaporative condensers will be there. What are the advantages and disadvantages? It is a simple design under low initial cost. Low quantity of cooling water is required. Small capacity of cooling water pump, means a very simple design and initial cost. Means don't think that it is saying compared to that other equipments, but it is in lakhs of rupees. This condensers will be there. Okay, low quantity of cooling water required. Small capacity of cooling water pump. Low operating cost. Low operating cost. Next, disadvantages. Vacuum maintained is very less. So that vacuum will be there. What is that vacuum? Air is zero is called as vacuum. So vacuum will be there. Very, it is not. That's a very most disadvantage. Okay, due to less vacuum work done per kg of steam is very less. It's steam generated, and the steam condensed is also very poor, very poor. But some applications only we are going to use it for this type of condensers, and are not suitable for medium and large power plants. Only small one we can use this. Uh, this thing. So another one is that advantages, surface condensers. What is that surface due to high vacuum increases, thermal efficiency and output of the plant. Due to high vacuum increases, very large vacuum increases, the thermal efficiency of the output is the plant. Condensate can be reused as a boiler feed water. Yes, always we have to use that condensate. Otherwise, water scarcity problem. So if that reverse is having water also, we cannot use So all these things. Okay. Auxiliary power plant requirement is very less. Okay. And the less amount of air is carried to that boiler, and any kind of feed water can be used. Okay. And can develop a high vacuum, so suitable for medium and large power plants. It is very useful for the uh, large and medium power. Maximum this type of condenser only we are going to use in power plants. Thank you, my dear friends. Next video, I will speak again. That's next video I will continue. Thank you.